Let's begin this session with homework exercise number 26 from section 9.3. Problem 26 states that from 80 degrees Celsius, 105 Celsius, 185, and 325 Celsius, select the best estimate of the Celsius temperature of the oven temperature cooking a ham. Well, cooking a ham, we know that in Fahrenheit degrees, it's going to be somewhere between, I'd say, 350, 400 degrees Fahrenheit. So what we want to do is we want to take the Celsius and convert. Now we know it's a fairly high temperature to cook a ham, so let's go ahead and start with the highest temperature, which is 325 Celsius, and we'll convert it into Fahrenheit. Now if you remember, the formula Fahrenheit is equal to 9/5 C plus 32. So if we put in 325, 9/5 times the Celsius, which is 325 plus 32, and we'll go ahead and do that on our calculator, and we'll get the right answer. Again, Fahrenheit temperature is 9/5 times the Celsius plus 32. So we'll go ahead and put that formula in one step and see what we get. 9/5, we can do 9 divided by 5 times, in parentheses, we'll try 325 right paren plus 32, and we get 617 degrees, which it appears that would be too high of a temperature. We don't cook meat, pork at 617 degrees. So let's go ahead and try 185, okay? So 185 is the next highest, so we'll do Fahrenheit is equal to 9/5 times 185 plus 32. And again, do it on our calculator. 9/5 we can put in as 9 divided by 5 times, use parentheses, 185 plus 32, and we get 365 degrees, which makes sense, right? We cook meat in ovens about 350 to 400 degrees Fahrenheit, so we'll go ahead and we know that 185 Celsius is correct. 105 and 80 Celsius would be too low of a temperature. The meat wouldn't cook. All right, very good. Let's look at number 27. A high temperature of 125 degrees was recorded in a desert. The high temperature recorded in the Midwest was 50 degrees Celsius. How much higher degrees Fahrenheit was the temperature in the desert than the Midwest? Okay, so we got to convert everything into Fahrenheit, right? Because we want to compare into Fahrenheit. So what we're going to do is we're going to take the temperature in the Midwest, 50, and convert it into Fahrenheit. So what we have again, the Fahrenheit is 9/5 times the Celsius, which is given to be 50, plus 32. So we can do that on our calculator to calculate the temperature in Fahrenheit for the Midwest. So again, the formula 9/5, 9 divided by 5 times 50 plus 32, and we get 122 degrees, right? And so the Fahrenheit temperature in the Midwest is 122. The desert was 125, so how much higher was the desert? So to find how much higher, we subtract 125 minus 122, and we get 3 degrees Fahrenheit difference. Remember, we did it in Fahrenheit, so it is indeed 3 degrees Fahrenheit. All right, very good. Okay, number 28. We have that determine the quantity needed to replace the question mark to make the scale balance. Weight times distance on both sides of the fulcrum. The triangle must be the same to make the scale balance. Okay, so it's weight times distance. Now, let's go ahead and do everything. We have to do everything in the correct number of units. So we have kilograms here, we have grams here, right? Meters here, centimeters here. So let's do everything in we want our answer in grams. So we're going to go ahead and do everything in grams. So right here, the 5 kilograms will change to grams. And again, kilo, hecta, deca, the unit grams by itself. So it's 1, 2, 3 jumps to the right. So 5 kilograms, 1, 2, 3 would be 5,000 grams. So then 5,000 grams times 3 meters is the product of the weight and the distance on this side. Okay. This side, the grams we don't know is x, and the number of meters, okay, but this is centimeters. So again, centimeters, decimeters, and then meters by itself, 2 jumps to the right. I'm sorry, 2 jumps to the left. So 600 centimeters would be 6.0 or 6 meters. So we're going to multiply x by 6 meters. Okay, so we're doing everything in in grams times meters. So when we get our answer, it will be terms in grams. So now we just have a simple equation to solve. 3 times 5,000 is 15,000 equals 6 times x. Divide both sides by 6. 6 is canceled, so we get x is equal to 15,000 divided by 6. Again, the weight and the distance are equal. I decided to do weight in grams and distance in meters. So weight in grams is x we're missing, and the distance 600 meters is 6 meters. So I get 5,000 times 3 equals 6 times x. Divide by 6 to solve for x. And 15,000 divided by 6, we'll do that on our calculator, will give us the correct answer. $2,500 grams. And that is indeed the correct answer, 2,500 grams. All right, very good. Number 29, if rice costs $1.25 per kilogram, determine the cost of a pound of rice. Okay, now, the cost per kilogram is the money goes in the numerator. So 125 per 1 kilogram. Now, we want the cost per pound. So pounds is in the denominator. So this is a little bit tricky here. The kilograms we want to cancel, but it's in the denominator here. So it goes in the numerator over pound. And again, if you go back to previous problems or view an example, 0.45 kilograms is equal to 1 pound. That's the conversion factor we're given or using. So 0.45 goes here, 1 pound goes there. Now kilograms cancel, and we get the cost in the numerator per pound, which is what we want. Okay? But now notice the 0.45 is in the numerator, so we're going to multiply. So 125 times 0.45 gives us our answer, but then it's in money per pounds because the kilograms units cancel. Okay? So we end up multiplying the amount of money, 125 by 0.45. Okay, $1.25 times 0.45, and that gives us 0.562. So the cost is 0.5625 to the nearest cent. Cent is 2 decimal places. The third decimal is a 2, so we would keep the 6 with the second decimal, and it would be 0.56 because you got a dollar sign, so it's less than $1, so we need a decimal 0.56. And that is indeed the correct answer. Question number 30. The recommended dosage of drug for a pediatric patient is 200 milligrams per kilogram of a patient's weight. Jane weighs 67 pounds. How much of the drug should receive? It's 200 milligrams per kilogram, so we first got to do what? Change 67 pounds to kilograms. So 67 pounds, and again, we want kilograms. okay? And we want to get rid of pounds. And notice if you look at view an example or previous problems, 0.45 kilograms is equal to 1 pound. So 0.45 for 1 pound. Okay, the pounds cancel and we get the number of kilograms. The 0.45 is in the numerator, so that means we're going to multiply. Okay, so we're going to take 67 pounds and multiply by 0.45 to get the number of kilograms. 67 pounds times 0.45 gives us a number of kilograms, which is 30.15. So now again, this is the person weighs 30.15 kilograms, and there's 200 milligrams per kilogram here, so you would just multiply 200 for each one of these, right? 30.15 of these times 200, and that would give us the milligrams, and we're going to round to the nearest milligram, which is a whole number, okay? So we'll take the 30.15 multiplied by 200 because it's 200 milligrams per kilogram. So times that number, 31.5 times 200, 6,030, and again, it's a whole number. It comes out to be a whole number. So we just put it in exactly as it is, and we get it solved correct. Very good. This ends this session, completes all the problems from section 9.3. If you have any questions, send me an email at tsquares@hodges.edu or call me at 239-938-7805. Thank you.